Hello and welcome to another session of my Data Preparation for Data Science webinar. My name is Gerhard and I'm a data scientist and book author at SAS. Today we are going to focus on a data quality for analytics story, and I will show you how you can use data quality check data in order to analyze a Sailrace with SAS Visual Analytics. In this webinar, I would like to show you how you can answer 5 business questions based on GPS data. We will show how we can animate the race interactively and find out how we can observe different phases in the race, the distance of boats during different phases in the race, and how we can interact graphically with the data. We will also take a look on how we can perform speed profiling per boat on different phases during the race, when do certain tags, certain events happen during the race, how we can see this in the data. We will also perform a speed analysis and compare different boats, and not only compare speed, but also the distance which is sailed. We will also run a study on what is the speed behavior during the tack when the wind turns through the wind to get on another angle to the wind. How is the race behavior and the speed behavior there? And we will also run an analysis how we can analyze the wind conditions geographically. Are there areas at the lake where there's probably more wind or less wind, or a better angle of the wind? This is what we're going to do here, and we will use SAS Visual Analytics, where we have already loaded the data to run this analysis. The prequel of this webinar is a session which I already recorded, where you see how you can verify data quality for analytics using interactive data analysis. We have seen there that we found in our data some problems which we need to tackle before we could run the analysis. Beside the fact that I'm a data scientist, I'm also a passionate sailor, and I like to sail just for fun, and I also like to sail races. During a sail race, the layout is typically a layout as you see here, where boats sail or start against the wind and sail in an approximate angle of 45 degrees upwind, while they always do some tacking and change the direction until they reach the upwind bow, and then when the wind comes from above, they sail downwind in order to go to the start again and maybe do this one more round. This is the typical layout of a sail race. In the data that we are analyzing here, we see that our race layout has been tilted as the wind has been coming from approximately south-southeast, so the boats sail not into north direction but into south-southeast direction when they start. Let's now go to SAS Visual Analytics and analyze the GPS data that we have from our sail race. The first thing that we would like to see is we would like to get an overview on the race course and see how the different boats were moving over the race. So in order to do this, we take a bubble plot. We add this bubble plot here, and now we need to specify the different variables which we would like to use. On the horizontal axis, we take the longitude. On the vertical axis, we take the latitude, and as a color, we take the theme, which gives us an overview how the boats were different moving and which race course which belongs to which boat. I suggest we make this a little bit more quadratic because it gives us a better overview and more fair overview on how the boats were moving up. So we see here is the start at the downwind bow. Boats were going up by tacking to the upwind bow, to the second bow, and then going with wind from above down to the finish. So this is one look which we can have on our analysis. However, we would like to add a little bit more here and, for example, put some animation to that. In order to be able to add some animation here, we create some place for filters, and as a filter I suggest we add the sequence ID per team, which allows us to scroll over the race and get some individual findings for that. Let's make this a little bit larger here so we can easier select our data points and make this to 75%. So what we can do now is we can, for example, limit the number of available data points just to the first one. So we see, for example, the beginning of the race. So we see how the race started and boats were going upwind. Some of them were going to the left side of the race. The yellow boat you see very early tacked after the race. So some boats were going to the right side. If we now continue creating our time window, we see how these boats were going. Some of them going to the left, others going to the right, and we can see what benefit this had when they finally end up at the upwind bow. So we see, for example, these three boats, green, red and violet, went to the left side of the race course. The others went to the right side of the race course. And let's see how this looks like when they end up here at the upwind bow. Let's move this a little bit further. So we see already here that the green boat has quite an advantage compared to all other boats. It's very far ahead. Also the red boat is quite far ahead. So it looks like for these two boats, walking to the left side of the upwind course has been very beneficial. And if we move this further now, closer to the end of the race, to the end of the upwind course, we see that we have the green one reaching the upwind bow as first, the red one probably as the second, and then it looks like whether the blue or the orange is going next. So what we can see here by studying this in some detail is how different sections of the race course made it positive or negative, or turned out to be a good or a bad decision in order to end up at the upwind bow. In order to add here an additional feature, I suggest we add a box plot here, which allows us to display the speed of the boat. So let's take the box plot, add it here to the right, and as the data for the box plot, we go and say as the measure we would like to have the speed, and as the category we would like to see the team. So we see here on the right side the different speed in knots for the various boats. However, we need to be aware that this is for the entire race. If we would like to split this for the upwind or for the downwind part of the race, we can easily take here a category which I called section that I prepared earlier, which is the first half and the second half of the race before and after they reach the upwind bow, and just add this also here to the analysis. So let's go and just select here the downwind section, which also affects our upwind courses here that we see here. Let's now take a look at the speed which the different boats sails upwind and how they ended up at the upwind bow. And we see a couple of very interesting things here. For example, let's take a look at the orange boat. We see that the speed is significantly lower compared to the other 5 boats. It is on average half a knot slower compared to the other boats when it went upwind. However, we see that it still ended up as the third boat at the upwind bow because it sailed a very efficient race course. It tacked in a very intelligent way, always with the wind shifts, and therefore, although it sailed not that fast, or maybe it sailed not that fast because it sailed a very close angle to the wind, it still ended up very early upwind. Also, when we compare the green and the red boat, you remember green was going first, red was going second at the upwind boat. We see that the red boat was even sailing faster on average compared to the green boat. However, we also see that the green boat had a little bit better tacks in terms of not going out that at the very border of the race course and did not have to sail against a certain wind shift at the end. So little bit slower speed, but better decision in how to go upwind to the bow. So we see how easy it is to use a graphical tool like SAS Analytics to get a deeper look into the behavior on a race course. Where did the boat sail and what is the speed what they sailed and what might be the outcome and the effect of certain decisions. Let's maybe quickly take a look at the downwind course and move this here to the second part of the race and see how the downwind section looks like. Here we see, for example, that the green boat had a very fast downwind speed, faster than the others. Also the violet one has a very good downwind speed. And we can now see what this meant, how boats went downwind and in which order they ended up at the finish. Let's now take a look who won the race, and you might already guess that the green boat, who was already leading at the upwind bow, had in the second part of the race also the best speed, definitely won the race. So you see here a couple of seconds before reaching the finish, it is quite far ahead. And if we move forward the timeline, we see the red boat approaching next. Although it did not sail that fast, if we look here on the right side at the speed box plot, it is not as fast as the others. However, it sailed quite a direct way downwind and therefore also had some gain out of that. So we see when we move into the finish line, we see that red goes second. And here if we scroll on the data, we see that orange, blue and yellow being quite close to each other. However, we also see, for example, if we compare the race course of the blue and the red boat, we see that they almost went the same course, namely going quite direct to the finish. However, we see that and were therefore a little bit slower compared to the other boats who sailed a faster course with more distance. However, we also see that the red one was doing at the same section of the race on average faster compared to the blue one. So this also gives an indicator that they have been quite better on the downwind course, and therefore the blue one could not catch up as expected. Let's now do a more detailed analysis on speed and distance, and for that we just go and duplicate our analysis here. So we go and say that we would like to duplicate this page. However, on this page we do not want to have this slider anymore. Instead, we would like again to be able to differentiate between the various sections of the race. And also, instead of the race course, we would like to create a bar chart of the distance sailed. So here we have the speed in knots. However, we would now like to have a second variable, which gives us not the speed, but the distance sailed, how much meters were, for example, sailed in 1 second. This variable is not available in the GPS data that we loaded. However, you can very easily create such an additional data item, for example, just by clicking here on New Data Item and add a calculated item here with various formulas, with various functions which you have, and with different clauses. I have already done so and have created here a variable which is called distance in meters per second. And you see the formula that I used here. As the speed is calculated in miles per hour, and a nautic mile is 1,852 meters, I need to recalculate the speed by multiplying it with 1,852. And in order to move from hour to seconds, I need to divide it with 3,600, which are the seconds per hour. As my GPS data is only recorded on a 2-second interval, I need to multiply it with 2 to have the appropriate number here. So this formula, which you can either do here by typing it into as a formula or by visually pointing and clicking it, allows me to recalculate the speed in knots into meters per second. We would now like to create here a bar chart for that, and in order to do so, we just go and say we would like to have again a bar chart per team, and the length of these bars, we just go and say we would like to have the length not as the frequency, but with our new variable distance in meters. Remove the frequency, and we also remove as a filter the bows which here are still contained in the data. So what we see here is now a chart which shows us at the left hand side our distance in meters sailed per boat, and on the right hand side we see the average speed. And we can now filter this, for example, for the upwind part. We see that most boats were going around with something like around 6 knots. Not only the orange boat going slower, which also has an effect here. What is the average distance in meters sailed per 1 second, which we can also compare here. So we can very easily create a derived variable and not only visualize speed, but also relate this into another dimension. What is the distance sailed for the upwind section or also for the downwind section? We also saw earlier that the green one was sailing very quickly, so did the most meters per second. And we also learned that red and orange were sailing slower, did less meters per second, as they sailed very directly. Let's now study the race course and the speed over time per boat individually and create a chart as we see it here. However, I would like to demonstrate to you how you can do this individually and how simple that is. So we create a new page. Again, we say we would like to expand our page controls and add the variable team into it so that we can select the team we would like to see here and say this as a button bar. So we are ready to select per team. So the next thing we would like to do is we again would like to see the race course. So we take a scatter plot and add it here, and in the scatter plot we go as the measures and add the longitude and the latitude, and as a color we add the team. So same picture as before. However, if we now click on a certain boat, we see individually for this boat what was its course going upwind. The second thing we would like to see here is now an object which allows us to study the speed over time in more detail, and I suggest we do a line chart here, adding this line chart, and as a variable we do the sequence ID, which we have, and add race time as a variable here, and as a speed variable we take the speed, and again we remove the frequency. So let's connect this graph with the left one in order also to get the orange color. And here we see now on the left hand side the race course, how the boat was going upwind. And we also see here in the data the speed. So it's very easy for us to see that here this drops in speed. For example, this one, if we highlight this, we also see on the left hand side highlighted that this was the phase where the boat was tacking. Speed was going down. After the tack, speed was going up again. Here is the second tack, and here is the last tack. So it allows us to combine the speed behavior, which is especially interesting on the upwind course. How does the speed break down during tacking, and how does it come back again afterwards? We would now like to analyze this a little bit in more detail and take out these individual phases here, 15 seconds before and after tacking, also this one and this one, for all boats, and have a combined view on how they do vary tacking, who is tacking very fast, who is tacking very slow. Let's have a look how this looks like. Let's now take a look how we can analyze the different tacks and move to a new page. And in the data I have already prepared two additional variables. I have a variable where I have the tack phase time. So I identified the tacks of all boats in the data, and I added plus minus 15 GPS data points before and after the tack as an indicator in order to be able to select them now for our subgroup analysis. And I also have a second variable which I call distance in tack. What is the sail distance from the beginning until the end of the tack, in order also to see what is the speed behavior here. Let's have a look how this looks like. As an object, we add here a line chart. In the line chart, we move as the variables. We add here the tack phase time. As a group variable, we add team, and as a speed variable, we go and add the speed here. So what we see here in this analysis is now the phase 0. This is the time when the boat moves through the wind. What is the speed before and what is the speed after? So what we see here is all the 5 different boats. What was the speed sailing before the tack, during the tack, and after the tack? And we see there are some differences for certain boats. For example, let's take the yellow one. It is with average speed before the tack. However, it goes through the tack obviously quite smoothly, because it is by far the fastest boat after the tack when the boat goes on the new course. And it therefore sails very early already with high speed after the tack. We see that the orange boat, which we also already saw earlier, which sails not as fast as the others, however also during the tack does not lose so much difference, and goes up to its normal speed again quite quickly. However, its normal speed is not as high as the other boats, so what we can also see here in the analysis. We also see the blue boat tacking a little bit delayed. However, this delay and going smooth into the tack does also result in it takes quite a long time until it goes up with its high speed again. So we see that they were coming with a lot of speed into the tack, but it took quite long until they go on high speed again. Very interesting analysis of the tacking behavior, and we see that the yellow boat did really great here. Let's have an additional look and add another line chart here. And add this line chart. However, here we populated again on the time axis with our tag phase time. However, on the horizontal axis, we would like to see the distance in tag. So not the speed, but the distance sailed. And again, divide this by our teams. So what we see here is now quite interesting in terms of what is the sail distance from before and after the tag. So we see during the tag phase here, the sail distance does not increase as much as earlier because the boat is moving slower. And we see the blue boat, who was coming with a lot of speed into the tag, lost some speed here. And it is again, what we found earlier is the yellow boat, which recovers very quickly, and the speed goes up very early again on full speed, which also means that the sail distance during the tag, so the meters made good to the upwind bow, is much more compared to the other boats. So we can use this analysis from our GPS data after we have quality checked and after we have prepared them to analyze really interesting different behavior between boats on the race course. This is something which you can do here in SAS Visual Analytics in a very interactive and nice way and provide some very interesting insight how the different boats are tacking and how they are moving over the race course. In our last example, we would like to study the race course geographically a little bit more in detail and would like to create a map which shows the average speeds of the speed which the boat sailed there. In order to that, we create a new page, and in this new page we will go and add a heat map. Let's do it again. Adding a heat map here, and in this heat map we add on the horizontal axis and the vertical axis we add longitude and latitude as we did earlier, and as a color we add the speed. In order to show this now with colors which are easier to interpret, we will go on the one hand side to create this again into a quadratic race layout, so it's easy for us to interpret that. And with the colors in this race layout, we say we would change the color gradient from yellow for slow movements and for violet for larger movements. So we see here now the race layout from depending with colors for different speeds. The more dark, the more violet, the faster, the more yellow, the more brighter, the slower. However, we have to be aware that we are combining here the upwind and the downwind course, so maybe it makes sense to again differentiate between the upwind and the downwind and apply a filter here for the upwind and the downwind category. Let's go for that one, and let's just select the upwind category. So we now see here the upwind category, and we see that in colors now what is the boat speed in different areas of the race. We see when boats were tacking, for example like here, the color goes into the more yellow area because during the tag boats loses on speed. However, we also see on average there are quite deep violet areas, and we see that most boats sailing here on the right hand side of the race course had deeper violet colors compared to boats sailing here on the left-hand side. So if we had such data from more races or from over a longer period of time, we could investigate in more detail where on the lake we probably have better wind conditions because boats sail faster, or probably where is the angle to the wind when going upwind better compared to other sections. So with such a mosaic plot, and here we only have 6 teams for one race, if we had more data, we could draw a very good mosaic or contour plot, which gives us insight where do we have very dark violet sections and where do we have brighter sections where it's probably not advisable to sail into these sections. This is also possible here in SAS Visual Analytics when you analyze it graphically. So what we have seen here mosaic plots, we have seen here interactive plots that allowed us to compare the analysis. We have seen plots where we studied the speed, and we also found out how is the behavior during the tacking phase before and after, and how do boats come up with the speed. In this webinar, we have seen 5 business analyses which we performed on GPS data using SAS Visual Analytics. So we saw how we can animate the race, how we can perform speed analysis, how we can analyze and compare speed and distance per boat. We studied the boat behavior while they are tacking, and we also analyzed geographically where are probably better wind conditions. From this analysis, we have learned that it is very powerful to use interactive data analysis and to perform analysis with the data. Business expert can dig into the data and can answer business questions, which would be hard to see otherwise. We've also seen that many relationships in the data are only being understood well if they are being profiled graphically. So touching the data, visualizing them, and also having the interactive capability, as we saw here in our analysis, is key for that. We also learned in this and in the previous webinar that having correct data is key for such analysis, and this is also something which I have summarized in my data quality for analytics webinar. And it has been a lot of fun to perform this analysis for me as a data scientist and a sailor. Today we are focused on data quality and an application of visual data analysis. In other webinars I'm speaking about how you can assemble your data, how you can generate features and prepare the data for the analysis directly. And I'm always combining the topics how you prepare, how you quality check, but also how you can analyze this data. This has also been the topics of my SAS Press Books that I published recently. More content about these topics can be found in my Medium and LinkedIn articles, in my YouTube webinars, in my SAS Community Articles, and all the content is also published on GitHub. Thanks a lot for watching. It has been a pleasure to talk to you, and look forward to meet you soon in a future webinar.